everyone, so I'm back again with a PyTorch tutorial. Make sure that you have selected your GPU. Install this dependency because we are going to do the clustering examples today. So let's import our dataset. This time let's use the archives NLP dataset because we are going to learn about the topic modeling and all. And let's bring the abstract and title from this dataset because this is what we get. And we only have the train in this, as there is no validation and all such thing, because this is the unsupervised way of doing deep learning. So let's import high quality embedding from sentence based transformers. We are going to use the GT small model. Why GT? Because it's small, fast and good quality embedding model, and the output dimensionality is quite good. So we usually have about 384 dimensional vector per document. This is what you can expect. So let's see. Let's encode all of the abstract, and let's also show the progress bar. And let me copy the correct. Let's see, this is quite done. It's going to download the model first and then we are good to go. Let's see the shape. I believe it's going to take some time. Meanwhile, I'll just go to the Hugging Face and look at the model card, and I'll show you how you can get the exact callable functions. So search the model that I'm using, or any model, come to its model card, scroll down, and you'll see how to use that model. So it expects an string of array of strings, and then it's the same way that I'm going to follow it. So I'm going to fast forward this, and it's going to take about roughly 2-3 minutes. And in the meantime, we will be able to once it is done, and then we can move further and import the UMAP, which is going to be used for dimensionality reduction. And I mean, you must ask why embeddings? Because topic modeling is BERT topic, which works on semantic spaces, not on raw text. So for that we'll need to do some pre-processing of this text. So let's from UMAP, let's import UMAP. Import UMAP, and then UMAP, we need to initialize this. We need to specify how many components, minimum distance, matrices. We are going to use cosine similarity and a seed. So this UMAP will compress 384 dimension from above into 5 dimension. Because why? Because we are going to use the HDP scan, which struggle in the high dimensionality, and the topological structure that we are going to see becomes very much clear. And you must ask why 5 dimensions? Because it's enough to preserve the structure and faster clustering for 384 compared to 384 dimensions. And the distance I'm picking 0.0 because it allows the tight clustering. It will help us in doing better topic formulation. So let's call the fit transform method of this, and then we will be getting the reduced embedding, and then we can pass that to HDB scan. So meanwhile it is happening, let's import the HDB scan from HDB scan, and let's also initialize this. We need to define the minimum cluster size. Let's define 50 for now, and the metrics we are going to use the Euclidean distance, because now we can compare the Euclidean distance In the cluster selection method, we will use the EOM. It's better for stability. And then let's call it. So we are calling the correct function. And if you are wondering what is it, there is a very good documentation. What is HDB scan? What is, if you want to understand what is density based clustering, that also you can refer it, and it's a very good documentation to read. All of the internal formula and implementation are present over there, to make sure to check this out to have a better understanding. So yeah, so okay, so there's one problem. Let's correct this. This is supposed to be equals sign. Yeah, let it run. It's perfect. And now we can see the set of cluster. So let's use NumPy, and we'll use NumPy where cluster, where the look at the clusters and just see the abstract, some of the abstracts just for you to see what actually the input data looks like. Let's see for few words. There is an error. It says wrong key type. 313 is a type of NumPy in 64. Okay, expect an integer. So must be an error. This must be occurring during the slicing. So let's try to remove it. Let's try to hit again. Okay, I got it. So we have to actually pass. It is expecting us to pass the integer, but somehow it is sending the NumPy in 64. So we can convert that. We'll just need to typecast the indexed as integer. Hopefully it is going to work. So let's do that. See, this is where what I am asking. This is where it's breaking. So let's go there and type int, and it's going to work perfect. Now you can see the abstract itself. These are the document that we are trying to create the embeddings visualizations in the topological clustering. So for creating the visualization, we will need to use this reduce embedding, and let's make a data frame out of it. So here's the code. This is pretty much the stuff where we are going to create the data frame, and we actually want to store the UMAP coordinate and cluster assignment. So now from there we can create the cluster data frame and the outlier data frame. And -1 is the HDB scan outlier cluster, which is called the noise point, and we'll plot them separately. And now we can call the plot. I'm at plotlib plotting the scatter plots. From there you will be able to see the reduced embeddings of this dataset. So let's call this function. If everything works fine, it should show us the plots of our embedding. Let's wait for it. Yeah, let's run it. There you can see how good clusters have, our dense cluster has been made. See, it's beautiful, honestly, if you ask me. So from the documentation we were able to create such a density based clustering, which is nice. Thank you for watching this session. Bye.